percent. So the original price was 100%. It was reduced 14% so that the new price would have been 86%. And so they reduced the price 14% to be able to sell the car for $3,440. So this is the actual dollars. So they sold it for $3,440. And the question is, what was the original price? What was the original price of the car? These are in percents. I'm going to do cross multiplication. So 1.0, converting the percents to decimals. Glad I have my trusty calculator here. Over 86%, or 0.86, equals X over $3,440. Cross multiplying, I have 1 times 3,440 is just 3,440, equals 0.86x. That's from cross multiplying this way, dividing by 0.86 on both sides, and I will do that. 3,440 divided by 0.86. So my original price was $4,000. So back up at the table, if my original price was $4,000, then I had to have reduced the price by $560 to arrive at my new price. So that's problem number 2. That one was kind of hard, huh? All right, let's look at number 4. Number 4 says the ratio of eloquent to inarticulate. So a ratio is eloquent to inarticulate. That's what it looks like. The ratio of eloquent to inarticulate was 3:14. If there were 102 involved in the dialogue, so that's total. So eloquent, articulate, so we have to do total here, which is 17. And so that would be 3/17 were eloquent, 14/17 were inarticulate. So if there were 102 involved in the dialogue, that's 102 total. Then how many were eloquent? So that's what I'm solving for. How many were eloquent? So eloquent is 3 out of 17 total, equals the number eloquent in this new ratio over 102. Again, I'm going to cross multiply. 3 times 102 equals 17 times the number that were eloquent. Eloquent, that's hard to say over and over again. Divide by 17 and you get your total. I will do that to figure out how many were eloquent. And it is 18. 18 of the 102 were eloquent. Okay, that's number 4. We'll do 7 through 9 next on the next page. So we have to turn the page. And so that goes back. 7 actually goes back to problem 6. And it wants a frequency diagram. Okay, so we're going to be in the 30s. I'm going to do the stem and leaf plot first. So this is number 7, but I'm going back to do a stem and a leaf plot. So we have 3s, we have 4s, we have 31, and then we have 4. I'm not going to write them in any order. I'm going to write 1, 3, 8, 5, 7, 2, 0. I also have a 39. Okay, 50s. Let me count the numbers. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I have 20 numbers total. All right, and in the 50s, I have 2. I also see a 35 I missed. I have 52. I have 51. I have 54. I also see a 38 I missed. I'm in the 50s. I have a 54. I have a 53. I have a 59. And then 63, 65, 62. Let me see if I have enough numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I do. So a frequency distribution for number 7 is your histogram. So on, what is this? It's number, okay, so it's number of people are going to be here that kicked the ball. The distance, no, this is actually the distances the ball was kicked. So it's not the number of people. This is the distance. How many, well, it is the number of people. Number of people that kicked it that distance. Number of people that kicked, sorry, I can't keep it, kicked it this distance. And here is the distance on the x-axis. So we're going to have 30 to 40 to 50 to 60. So we'll start here. That's 30. Sorry for the crooked camera. 40, 50, 60, and I'll go out, okay? All right, so there are 4, let me see, 2, 4, 6, 7. So we'll do this in ones on the y-axis. 1, 2, 3, 4, 5, 6, and we'll go up to 7. So 4 people kicked it between 30 and 40. So that's 4. Okay, between 40 and 50, 2, 4, 6, 7. 7 people kicked it. Okay, between 50 and 60, I should have put 70 down here. 2, 4, 6 people kicked it, so right about there is 6. And then 3 between 60 and 70. All right, so determine the mode. The mode is the most. Looks like we have 2 54s. So that appears to be the mode, 54 is the mode. Then it says determine the percentage of the distances that were 49 yards or less. So percentage, 49 or less. So I'm going from this part of the table down. So we had 7 and 4, 11 under 49 over 20. That is our percentage. Okay, it's just 11 divided by 20 as a percent, and that's 55%. All right, that's number 7. Number 8 says Leanne had a blue velvet bag. Here we're back to probability. And I'll look at the book while I erase. So she has this blue velvet bag. Hey, at least we're not talking about an urn, right? Okay. Blue velvet bag. It contains 10 diamonds and 8 sapphires. Sapphires, Paula. She draws one gem at random and does not replace it, then draws a second gem at random. What is the probability that she draws a diamond first and a sapphire second? So, first draw, we want a diamond. We're not going to put it back because it's jewels, and you would not put jewels back. Second draw, we're going to draw a sapphire. Well, the first time I draw, I have my positive outcomes would be 10 because there's 10 diamonds in it, and I have a total of 18 jewels in the bag. This next time I draw, I do not have 18 jewels in the bag. I did not put the diamond back, so I only have 17 jewels, but I have 8 sapphires. Before I multiply, I simplify, right? 2 goes into 8, 4, and into 18, 9. And my result is 40 over 17 times 9, which is 153. And I do not believe that that can be simplified. It cannot be. That's my probability. 40 out of 53. Now, for my domain, all right? So we're going to be looking at domain for number 9. And I'm looking in the book. It says, which of the following diagrams depicts a function? I was moving to get a pencil. The first one, remember, for a function, every x can have one and only one y. For A, 4 only goes to 5, 3 only goes to x, 2 only goes to x. It is a function. For B, there's a problem. Y goes to both C and B. It is not a function. For C, A only goes to P, X only goes to P, 1Y, 4 only goes to M. It is a function.